Okay. Okay. Today we will study the paper from Marine Pollution Bulletin titled Mapping Marine Litter with Unmanned Aerial Systems, a showcase comparison among manual image screening and machine learning technique. This paper was prepared by Portuguese researchers. I will read the abstract. Recent works have shown the feasibility of unmanned aerial systems for monitoring marine pollution. We provide a comparison among techniques to detect and map marine litter objects on a UAS-derived orthophoto of a sandy beach dune system. Manual image screening technique allowed a detailed description of marine litter categories. Random forest classifier returned the best automated detection rate, while convolutional neural network performed slightly worse due to higher number of false positive detection. We show that the automatic method allows faster and more frequent surveys, while still providing a reliable density map of marine litter load. Image manual screening should be preferred when the characterization of marine litter type and material is required. Our analysis suggests that the use of a UAS-derived orthophoto is appropriate to obtain a detailed geolocation of marine litter items, requires much less human effort, and allow a wide area coverage. So we can understand that they are trying to show that the image from a drone can be used to generate marine litter density map on beach. Let's check the figure in table first. Let's go to figure 1. Figure 1 is showing survey location in Portugal. The photo is a bird's eye view image of a surveyed beach, and you can see the drone, DJI Phantom Pro 4. And B is showing the also photo, mosaic photo of a surveyed beach, and the numbers are showing that the area for training and validation of a machine learning process. And orange line is a beach profile elevation of a surveyed beach. And next, figure 2 is showing the workflow for manual image screening. We can understand that the input is orthophoto of a surveyed beach, and the surveyor make the grid of 2 meter by 2 meter on photo, and when the surveyor found the lit item on the orthophoto, the surveyor mark that area and make some kind of attribute table to generate this kind of a marine litter map for the surveyed beach. Next, figure 3 is showing the workflow for random forest technique. For random forest technique, surveyor makes some kind of mask for the litter on beach on orthophoto, and they use various kind of color spaces for this masking and kind of a decision-making system for machine learning. And then they make some decision tree for the best prediction model for random forest. And then they trained the trained the computer to detect marine litter on orthophoto. And then they evaluate the result from random forest. If the centroid of the marked area is within 34 pixel of the photo, it can be evaluated as a true positive decision of a random forest. Next, figure 4, showing the workflow of convolutional neural network, CNN workflow. For CNN machine learning, they made some kind of patch grid from the photo pixel, and they mark some litter. The surveyor designates some area as a litter or no litter area, and then they can make this kind of a dense net to classify some block as a litter or no litter area on orthophoto, and they evaluated the result from CNN with the criteria of 34 pixel from the centroid of the litter on orthophoto. Then next, table 1 is showing the performance, statistical performance from each technique compared to manual screening. We can understand that the random forest and CNN performance was better in area 2 than area 5. And for the techniques, random forest is better than CNN in area 2 and area 5. The precision and recall or F-score of random forest is higher than CNN in area 2 and area 5. So we can understand that the accuracy of random forest was about over 70% in area 2. Okay, next. Figure 5 is showing the comparison, the result from random forest and convolutional network in terms of type and color of marine debris on orthophoto. We can understand that accuracy of random forest for type identification is over 50%. The lowest percent is 54 for pink. It's maybe polystyrene pieces is the lowest, but for plastic pieces or machined wood, the accuracy would be higher than 70%. For color, also showing higher percentage for detection. But convolutional neural network showing slightly lower percentage in detection. We can see the pink fishing string is 47%. For color, the CNN show us over than 50% of accuracy in detection of marinita from OSA photo. So we can say that these two machine learning techniques worked comparatively well in detection of marinita from OSA photo. Figure 6 is a comparison among the detection of OSA photo from the OSA photo. The green dot is accurate, the true positive result. Red is a false negative. Blue is a false positive. I mean, red means false negative means machine learning did not detect marinita, even there were marinita on beach. Blue means false positive. It means there was no marinita, but machine learning technique said that there is a marinita on beach. Next, figure 7 is a density map of a marinita of the beach. A is a manual image screening. The right is image from image screening. The center is a random forest, and right is a convolutional neural network. We can see that the machine learning technique has some kind of higher density in their density map. And B showing the underestimation and overestimation of machine learning technique. Red means underestimation. It means machine learning missed marinita on beach or from the photo. Blue means overestimation. It is a false positive result from the machine learning technique. So we can see that random forest and CNN both produce some kind of overestimation in this accumulated area. But also authors are saying that this machine learning technique was successful in detecting marinita accumulated area from the OSA photo. And then finally, the table 2 showing the assessment of each technique for marinita monitoring on beach. So we can say that manual screening can be used for identify item type, color, and geolocation and density map of the marinita on beach. But random forest and CNN and cannot identify item type or material or weight, but they can produce or detect item color, geolocation, and can produce a marine litter density map. But in situ visual sensors can be used for identification of item type, material, color, but cannot applied for produce item geolocation or cannot produce marine litter density map because we cannot geolocate each item on beach with in situ visual sensors. If we want to do this, we need to mark every single location of the litter item on beach. It takes a lot of time. Okay, that's all of figure and table. Okay, let's get back to the introduction. Do you have any question or comments for figure and table? Okay, I will start with the introduction. All we are interested or involved in marine litter monitoring. They are starting with this paper with defining monitoring as the practice of repeating a series of measurements of marine litter abundance and characteristics on the environment in order to detect trends and load change of pollution in space or time. It's from Gessamp report. And we want to know the source or the health threat from pollution like marine litter, and we want to know abundance, and we want to provide basic information to make policies to address marine litter issue. In marine environment, coastline is an important compartment to be monitored because they have multiple sources, and people mostly use coastline, so we should monitor the situation of marine litter in coastline. For the marine litter monitoring on coastal environment, we usually use in situ visual sensors method, like Korea Marine Beach Litter Monitoring Program. Many countries or entities are conducting this kind of in situ visual sensors marine litter monitoring on beach or coast. There are many guidelines and protocols for these in situ visual sensors monitoring. But this in situ sensors method need high demanding of human work, time, or the limitation in space. The in situ visual sensors can be done only on accessible beaches. But compared to in situ visual sensors method, aerial imagery surveys are developed very rapidly recent year using drone technology. It can be alternative of cost efficient to collect a high resolution image of the marine litter on beaches. So these UAS systems, the technology can be done for marine litter monitoring on coast. These UAS are usually conducted in altitude of 10 meter to 30 meter. The satellite image can be used, but the resolution would be not that high, and it would be very expensive. But the satellite image can be done in same flight phase for monitoring. And next, the orthophoto from the drone would be useful product from this UAS monitoring. And from the orthophoto, for detecting marine litter from the photo, the manual screening or automatic machine learning technique can be used. The detection rates were reported from 60% to 80% from previous study. Many researchers trying to develop this automated marine debris detection technique, but it has some technical challenges, like resolution or it needs develop the image processing technique, or we need some kind of threshold method for identifying marine litter from these photos. So authors applied two kinds of machine learning technique to detect marine litter from orthophoto, namely random forest and convolutional neural network. So the objective of this study is to give an overview and comparison of three approaches, including manual screening, random forest, and convolutional neural network. So they are trying to show that UAS is affordable and it can be useful in coastal pollution monitoring. Okay, this is introduction. May I go to method? Okay, method, they are showing a study site with figure 1 is Cabedelo Beach in Portugal. This beach is affected by river estuary for marine litter input, and they use the DJI Phantom 4 Pro to take the images of 200-meter long beach of Cabedelo Beach in a sunny day morning. The drone fly the altitude over 20 meter, and they made some also photo from programs. And prior to flight, they conducted traditional visual sensors according to OSPA standard method for beach litter monitoring. And next, they are explaining the the detection method detection from the orthophoto, the manual screening and machine learning, and machine learning including random forest and convolutional neural network. I think I've already explained it with the figures. Okay, let me skip this part. Okay, and then they want to check the performance of each technique, so they calculated the score. They evaluated with the performance with the F score and precision and recall from the result. Precision means precision means the ratio of true positive from true positive and false positive, and recall means the ratio of true positive from true positive and false negative. And F scores are a combination of precision and recall. Okay, that was a method part. Do you have any question about the method?
No, go ahead, please.
Okay, result. For detection, the manual screening returned about 98% of items from the photos. I think this 98% is from comparison between visual in situ visual senses and the result from the author photos. So the marinator in the author photo, total number of marinator is 180 items. It was a plastic fragment and fishing string and polystyrene pieces and machined wood was numerous items in the beach. Yeah, we've already seen the ratio accuracy of each techniques. The lowest percentage of successful detection for random forest was a fishing string, polystyrene pieces, and octopus parts. For CNN, only fishing string had a detection rate lower than 50%. For fishing string, it was not easy to manually and accurately delineate the contour of fishing string. So it was very difficult to train the machine learning algorithm. And also the missed detection was from green object, like fishing strings. And then they talk about some difficulties in detecting some items. Also the machined wood was a kind of subjective choice in also in even in manual screening. And they have some problem in transparent items, but the detection rate was not that low. Next. we've already seen the performance score of each techniques. So F score was about 70% for random forest, but 60% for CNN. The low performance scores from the false positive result of CNN. It means CNN detect, or CNN has some tendency in false positive detection, and there are some difficulties in detection of a little item trapped among natural wood debris or in area of dune vegetation. From the Marine-Litter density map, they use a hexagon polygon to show the density of Marine-Litter on beach. And they are talking about false positive result of CNN, but they say that two techniques were capable on identifying Marine-Litter load from the beach litter photo, also photo. And they are explaining the error from white logs and red reefs. Red reefs, they say that the training areas, there was no rock or red reefs for the training, so the error was from this part. Okay, may I go to discussion? In discussion, they say that with the table 2, in situ visual sensors may provide a holistic characterization of Marine-Litter on beach, but is a time-consuming job. On the contrary, the manual screening from the orthophoto and the manual screening can present automated technique, but not capable of identifying the type of Marine-Litter, and also weight cannot be obtained by manual screening from orthophotos. Also, neither RF or CNN can produce weight information from the photo. But the geolocation is a kind of major factors making this kind of orthophotos useful for monitoring beach litter, especially in detection of accumulation areas on beaches. So it can be used for optimizing cleanup operation or designing automated cleaning system. And then they are comparing the time required for each technique. Yeah, I will skip. And they said that the processing and producing the result of counting, marking, and building attribute table from these orthophoto took about 1 working day for experienced operators. comparably short time to produce this kind of information from the author portals. They are talking about the limitation of manual screening, like subjectivity, but this kind of subjectivity can be complemented by field survey experience of operator of manual image screening. Yeah. For random forest and convolutional neural network, for random forest, it needs manual binary masking for Mariniter for training, and we need to manually digitize the contour of the object. It takes time. But for CNN, only we can make some fast work with marking centroid location of the litter on map. The CNN techniques are faster and easier job for detecting marine litter. But these two machine learning technique is impossible to categorize the marine litter item. But the strength of this kind of automated technique is opportunistic to their repeatability. So we can say that we frequently conduct beach litter monitoring with a drone and make marine litter density map with this machine learning technique. Random forest was done by MATLAB, and CNN was written by Python language from previous study. And they are talking about some issues in partially buried or transparent objects. But this was there was some advance in detecting this kind of thing with histogram of oriented gradient or footprint shadow problem was partially addressed with the development of technology of or coding. But we should consider the diverse local environment characteristics of a beach to conduct this kind of machine learning technique. Okay, in conclusion, yeah, they say that the machine learning technique was fairly returned the litter abundance map, but have some false positive feature in producing this marine litter density map, but it has a strength in repeatability. So the improving the training of a machine learning algorithm would be helpful in using this drone and machine learning marine litter detection method. Okay, that's all the contents of the paper. Okay, do we have any question or comments for this paper? Anybody?
No, thank you.
Hi, this is Jason from Taiwan.
Jason, hi, good morning.
Yes, yeah, hi, good morning. Thank you for sharing and explain this paper. And I'm curious. I think I can agree the author provides some I mean, in the discussion part, they say there's some limitation of this machine learning method. Yes, because in Taiwan we already, I think we already, I mean, there are at least five to six different groups. They try to use machine learning and artificial intelligence to survey the beach litter, but all they failed in Taiwan because those limitations, like the background, I mean the like the color of the sand or the some beach are sand or some beach are rocky shores, those kind of limitation. And I think there's another limitation they didn't mention. It's about the overlap of some in some hotspot area. The item can be overlap in a very dense amount or balance, and it is also difficult for this aerial image to calculate because they are all of the details are overlapped in big piles. So that's but by those hotspot area, it's more important for people to monitor or to survey those kind of areas. Okay, that is my idea.
Thank you, Jason. In Korea, there are several groups trying to develop this kind of machine learning technique to survey or monitor the marine litter distribution on coastline. They also have some difficulties in producing some useful information from their survey. I think it's all still needs a huge amount of time in preparing and processing and in interpreting the result for the implementation on marine litter management. As Jason said, that there are some difficulties in considering diverse characteristics of coast, like beach, sand beach, or pebble beach, rocky beach. They are all different. So this kind of machine learning cannot be implemented to detect marine litter because of their various colors of background of a marine environment or other things. Okay, any other question or comment? Okay. For wrapping this seminar, we have already understand that the machine learning technique has many limitations in surveying over marine litter, because but the drone technology is developing very rapidly, and the use of these kind of drones are popular, getting more popular. So people can easily participate in drone or marine litter survey, drone using picturing or drone using image taking can be like a campaign, and it can be developed some kind of a citizen science program. So we should follow up this kind of drone and machine learning technique for the development of marine litter management in coastal areas. Okay. May I wrap up the seminar? Okay. Then shall we talk about next seminar schedule? Oh, I missed one thing. Authors already published the other papers from their drone marine litter survey from the same beach. You can check the contents of this paper. And okay, let me check the calendar of next month. We can have a next seminar on 7th of July. Okay. Jason, would you please select one paper and share for us for next
Yes.
seminar?
Yes.
Okay, thank you. So see you next month on 7th of July
Okay.
with the paper.
Okay,
Yeah.
see you.
See you. Bye
Thank you.
bye.
Bye.
Thank you. Bye bye.